Hello dear students, in this session we will try to calculate acceleration and tension in case of Atwood machine. Okay, what is Atwood machine? There was someone called George Atwood. Okay, in 1784 by using this machine he verified Newton's laws of motion. Okay, what is this? How does this Atwood machine looks like? We will see. Before that, okay, you have to solve this problem. Okay, you have to solve this problem and you have to give the answer in comment section for me. The problem is like this: a block of metal weighing 2 kg is resting on a frictionless plane. It is struck by a jet releasing water at a rate of 1 kg per second and at a speed of 5 meter per second. Calculate the initial acceleration of the block. Okay, this is the problem. I'll give you a hint. Okay, I'll give you a hint. I think, see, rate of 1 kg per second. You will have to use Newton's second law, F is equal to dp by dt, or the equation F is equal to m into a, or you can use both. Okay, I have given enough hint so that you can solve problem. Still, you will have to think for 1 or 2 minutes. Okay, do it. Okay, or solve this after listening to this video. Okay, but do not forget calculation of tension and acceleration in case of Atwood machine. Okay, how does Atwood machine look like? So there is a fixed ceiling, there is a pulley. Okay, what is this? There is a pulley. Okay, now two masses are hung over this pulley. Okay, this string goes like this actually over the pulley. Okay, say this is M1. Okay, this is M2. This is how Atwood machine looks like. Yeah, now we will make some consideration. Okay, consideration is, in this particular case M1 is greater than M2. You can do anything. Okay, but in this particular case M1 is greater than M2. If M1 is greater, M1G will be bigger, M2G will be smaller, so it will have higher weight. Okay, so what happens? This system, M1 will accelerate downwards, M2 will accelerate upwards. Correct now? M1 is heavy, so M1 will go down, M2 will go up. Okay, hope you understood this much. Now what I'll do, I will draw free body diagram of M1. Okay, M1, and free body diagram of M2. Okay, on M1, which are all the forces acting on M1? M1G is acting downwards. Correct now? M1G is acting downwards, and here in the string there is a tension. Correct now? So force of tension is acting upwards. Due to these two forces, what is the direction of acceleration of M1? M1 is coming downwards. It is getting accelerated downwards. What about M2? So naturally there should be a weight. Okay, M2G is acting downwards, tension is acting upwards, but M2 is going up. Okay, acceleration is upwards. Now we know how to write free body diagram and how to write the equations. Okay, this topic is very important. Yeah, listen. Now here we write an equation, force equation, using Newton's second law. What is the net force acting? T and M1G both are acting. Which is a bigger force? M1G is bigger. Why? M1 is coming down, so downward force should be bigger force. So my first equation would be M1G minus T is equal to M1A, or this is the net force. Correct now? Is responsible for acceleration of M1. F is equal to M into A. Correct now? This is my equation number 1. Equation number 1. Here which is the bigger force? Tension is bigger. That is why M2 is going up. So what I can write? Tension T minus M2G is equal to M2A. Hope you understood how to write these two equations. Okay. Now I have got two equations. Now if I add 1 and 2, what happens? Okay. So what I am doing? Equation 1 plus equation 2 gives me we'll see that those two equations. 1 plus 2. Okay, here you have minus t, here you have plus t. T gets cancelled. Here m1g, here you have minus m2g. What do you get? m1g minus m2g equal to on RHS. What do you have? m1a is there, m2a is there. Okay, equal to m1a plus m2a. Okay, what happens? G is common. m1 minus m2 into g is equal to m1 plus m2 into a. We got acceleration. Our acceleration is equal to m1 minus m2 divided by m1 plus m2 into g. We got acceleration. We got an equation for acceleration. Okay. Now we have to find a tension. Correct? Now what we have to do? We have to calculate acceleration and tension. We will take one equation, any one equation. You have to substitute for acceleration either in equation 1 or in equation 2. Let me take equation 2. Okay, what is that? T minus m2g is equal to m2a. T minus m2g is equal to m2a. Here I'll substitute for a. What happens? Let us see. T is equal to, and I'll be throwing this m2g to the RHS so that it becomes plus. Okay, m2 into a means what? This is a. Correct na? m1 minus m2 into g, okay, divided by m1 plus m2. This minus m2g goes to the RHS and it becomes plus m2g. So what happens? Tension is equal to m1 m2g, m1 simplification, m1 m2g minus m2 square g, okay, plus taking LCM, m1 m2g, m2 square g, divided by m1 plus m2 divided by m1 plus m2. Okay. Now what happens? Minus m2 square g plus m2 square g gets cancelled. m1 m2g plus m1 m2g will be 2 times m1 m2g divided by m1 plus m2. So this is how you have to calculate acceleration and tension in the case of Atwood machine. Okay. Now you can remember this equation easily. Okay. How to remember this equation easily? One hint I'll give you. Okay. See. If you go to free space, say there is no gravity. Okay, there is no gravity. If there is no gravity, suppose what happens? Even though m1 is greater than m2, m1 will not come down. Why? Because there is no downward gravitational force. Correct na? Means acceleration is 0. If gravity is 0, g is 0. Correct na? If g is 0, acceleration should be 0. Correct. Therefore, g should come in the numerator. Then, one more thing. If m1 equal to m2, what happens? m1g will be equal to m2g. There is no unbalanced force. Correct na? There is no unbalanced force. So acceleration will be 0 if m1 equal to m2. So therefore, m1 minus m2. See, if m1 equal to m2, m1 minus m1, 0. Acceleration is 0. So therefore, m1 minus m2 should come in the numerator. Okay, hope you can understand. Like this, you can think. Or acceleration. What can be done? Acceleration equal to, you can remember this, like this. Acceleration equal to unbalanced force divided by total mass. Okay. For tension also I can give you explanation, but let us not do it. After 2-3 sessions I'll come back to this. Okay. Unbalanced force divided by total mass. What is unbalanced force? m1g is one force, m2g is another force. Correct na? But m1g is bigger. Why? m1 is greater than. So what is unbalanced force? m1g minus m2g. Unbalanced force means what? m1g minus m2g divided by total mass, m1 plus m2. What happened? G is common. What happened? m1 minus m2 into G divided by m1 plus m2. See, we got the equation directly. This is how you can remember. Okay, this may not work in all the cases, but in simple situations like this will work. Okay, acceleration equal to m1 minus m2 into G divided by m1 plus m2. Correct now. See, based on this, hope you understood this. Okay, m1 is greater. Okay, therefore m1 will come down, m2 will go up, and we are writing free body diagrams of the two masses. Okay, then we write two equations, then we simplify the two equations, we get the equation for acceleration, then we are substituting the acceleration in equation of acceleration in any one of the equations. Okay, then we will get tension. So what you do, you make a notes. After that, please do it on your own once. Okay, then next we will solve one problem. Say there is a Atwood machine. Okay, in one side you have a mass equal to 8 kg. Okay, on the other side you have a mass equal to 12 kg. Now in this situation, this is a problem. In this situation, what is acceleration and what is tension? Okay, so for simplicity, let us take G is equal to 10 meter per second square. You can pause the video here and you can solve it. Okay, you know the equations directly, or else just follow it and do the notes. So acceleration equal to m1 minus m2 divided by m1 plus m2 into G. What happens? m1 minus m2. So you take bigger mass as m1. Okay, 12 minus 8 into 10 divided by 12 plus 8. 12 minus 8 is 4. 4 into 10 is 40. 12 plus 8 is 20. So acceleration is 2 meter per second square. Very simple. Okay. Then what is the equation for tension? Tension is equal to 2 into m1 m2 into G divided by m1 plus m2. Okay, what happened? 2 into m1 is 12, m2 is 8 into 10 divided by m1 plus m2 is 20. So 10 goes 2 times. Okay, 2 and 2 gets cancelled. 12 into 8 is 96. 96 Newton. Tension means it is a force, no? 96 Newton. I'll tell you how to remember this equation also. Okay, see, yeah, say m2 is not there. Okay, say m2 is 0, then what will happen? m1 will fall down, m1 will be under free fall. Correct na? Then what is the tension in the string? There is no tension for the string because system is under free fall. Correct na? So therefore, when m2 is 0, tension should become 0. So therefore, m2 should come in the numerator. Correct na? m2 should come in the numerator. See, when m2 becomes 0, tension becomes 0. Okay, and one more thing. If m1 becomes 0, then m2 will be under free fall and there is no tension for the string. Okay, so therefore m1 should come in the numerator. Then what about gravity? If gravity is not there, if you are in a free space wherein there is no gravity, then these two masses will not have any weights. Weight will not be 0. Weight will be 0. Correct na? Weight will be 0. So therefore, say if you are in a free space, let us suppose that I cut this string. Then whether m2 will fall down? m2 will not fall down because there is no weight, there is no force acting on it. Correct na? And tension is also the 0. Why? Why the tension comes? Tension comes because of the weight. If weight is not there, tension is not there. Correct na? So therefore, in the equation of tension, G should be in the numerator. Okay? Yeah, G should be in the numerator. Hope you can understand this. And also you solve the problem which I have given in the beginning. Do not forget. So this is the problem. This is a simple problem. This problem can be solved using the equation F is equal to dP by dt and F is equal to m into A. Both are different forms of Newton's second law. Okay. Hope you understood the calculations of acceleration and tension in the case of Atwood's machine. Thank you very much.